Hey, Chem Kids. Well, it's what, 3 months into chemistry class, and we are finally ready to talk about chemical bonding. That took a while. So let's go ahead and see, how do atoms come together to form compounds? So our essential questions: what is a chemical bond? That's really kind of an essential question, overarching essential question for Unit 6. How do metals bond to one another? That's what we're going to talk about today. And what does it mean for an element to have a metallic nature? So hopefully you've already seen the Khan Academy video that talked about metallic nature, and we talked about elements that have extra valence electrons, plenty to go around, and that's what's going to give us our metallic bonds. So there are three main types of bonding that we're going to be talking about in this unit. Metallic bonds are metals only. That's a bit of an oversimplification. Occasionally there are some non-metals sprinkled in there, but with metallic bonds, you have a majority metal atoms involved. Okay, ionic bonds we're going to talk about in another video, where metals bond to non-metals. And then covalent bonds are when non-metals bond to non-metals. And we know that there aren't actually that many non-metals on the periodic table, but you'd be surprised how many combinations they can form. All right, so metallic bonds. Metallic bonds are the bond that hold the metal atoms together in a solid. And as we know, metals are more often than not solid at standard temperature. Okay, we know that metals hold on to their valence electrons very weakly. They actually want to get rid of them. They have extras. And so we can actually, it says that it holds the metal atoms together, but let's actually think of them as being positive ions, right? What do we call these again? If they're positive, they're cations. And so they are really just sitting among a sea of electrons. There are so many extra valence electrons that those electrons are just providing this sort of cushion. They're making space between the positive ions, and so that sea of electrons is really what gives metals their properties, the things that we think of as being metallic properties. So let's take a look at our sea of electrons. Let me see if my animation works for you here. We want to keep in mind that those valence electrons that are sort of just being distributed among all of those positive ions, right? Think of the positive ions, the metal nuclei plus their core electrons, and then the valence electrons are just floating freely among all of them. They're not connected to any particular nucleus. So they are free to move through the solid. That allows metals to conduct electricity. Okay, so as Sal Khan pointed out, you could, this is getting into some physics stuff, but you could put a voltage, like a difference, put some negative charge at one end of, say, a wire. That's typically what we do, and a positive charge at the other end of the wire, and that causes those electrons to move towards the positive, causing a flow of electrons. And that is what electricity is. It's a flow of electrons. So that's why metals can allow that, because they have these free floating electrons that are allowed to move throughout the solid. Okay, so let's see if this little video will play for you. Take a look. These are our positive ions, right? And you can see that they're all together in a solid, but the little blue things are the electrons that are just able to move about among those ions. Okay, the outermost electrons move freely, forming a sea of electrons. And it's the fact that these positive ions are sitting in this sea of electrons. That's what holds that solid together. The ions don't really feel any need to move apart. This is why they have high melting points. Let me see, what else does this say? Metal ions are attracted to and hence held together by the sea of electrons. That is the bond. Okay, so the movements of the electrons are random typically, but if you put that voltage difference on one end or the other of the wire, that causes the electrons to move in a particular direction. That's how we control electricity. All right, so hopefully that makes sense to you. Let's see. Metals have high melting points and especially high boiling points. We never really think about a metal boiling, right? If you can imagine metals in a gas state, it would have to be incredibly, incredibly hot for that to be the case. We can melt metals, and that's often how we like mix them. That's something that humans learned how to do back in, was it probably the Iron Age? But you do have to get them, for the most part, metals, you have to get them very, very hot in order to melt them, in order to break that metallic bond and allow the positive ions themselves to move about freely. Okay, it takes a lot of thermal energy, right? A lot of heat. You have to get it really hot. What else? Metals are malleable. They can be hammered into shape. You can shape them into all kinds of shapes, whatever you want to shape them into, they will be agreeable. You can even hammer them out into sheets. That word malleable comes from the Latin for hammer, or maybe you know the word mallet. It's the same root. Okay, they are ductile. They can be drawn into wires. A duct is typically like a tube type of thing. So that word duct also comes from the same root, meaning we can draw them into wires, which makes it very convenient because not only can they be made into wires, but they also run electricity, and that makes our technology today possible. They are shiny. They reflect light or have what we call luster. And that's all those electrons that are just sort of on the surface, reflecting the light back at us. All right, so let's look at this graphic. Isn't great, but it, maybe it'll show you a little bit what we're talking about. Imagine this is your hammer, right? And this is that set of positive ions. Now imagine the sea of electrons is just running about in between all of these things, right? Like little free-range children running amok, not connected to any particular parent atom. And so if we were to apply pressure on this side of this little solid, this little sample of solid, what happens is those things can just move in any old direction because the sea of electrons cushions those ions from getting too close to any other positive ion. And what would happen if two positive ions got too close together? Well, they would repel each other, and then you would have the piece break. But that doesn't typically happen, or it doesn't always happen easily with metal, because the sea of electrons sort of provides that cushion and allows them to move, allows the ions to just sort of change their position when pressure is applied. I think that might be the end. Oh no, we've got a couple more little pieces of information here. So we know that the electrons exist in these fuzzy clouds, and those fuzzy clouds allow the atoms, the ions, I should say, to slide around and not have to get too close to each other. Yeah, that's all we have. Hopefully that made sense. You can try that fill in the blank mastery check, and I will see you in class.